So 1.7 is linear inequalities and absolute value inequalities. So we will start off with the linear inequalities. As a matter of fact, let's go with the linear equation first. Excuse me. Let's do x equal to 2 first. All right. So when we look at the difference between a linear equation versus a linear inequality, we dealt with linear equations up to this point. The linear inequality is what we're looking at now. The first difference is that the equation has an equal sign. Your inequality uses one of your inequality symbols. So here we're using greater than. So when you solve this equation, you have x is equal to 2. When you solve the inequality, it was solved out to give you x is greater than 2. All right. So x equal to 2 is one solution. So your only solution is 2 for the equation. But when you solve a linear inequality or any inequality, that's infinitely many solutions. So remember, a solution is a value that makes your statement true or makes your equation true. So when is x plus 5 equal to 7? That's when x is equal to 2, because 2 plus 5 is equal to 7. In your inequality, you're saying when is x plus 5 greater than 7? So that's when x is greater than 2. You have infinite amount of solutions to plug in. So in other words, 2.1 would be a value you can plug in for x to make the left side greater than 7. 100 is something you can plug in. 5 million is something you can plug in for x to make it greater than 7. So all values greater than 7 will be a solution. And also I said this is also considered a solution set. So it's not just a solution, it's a solution set. All right. Questions on the differences? All right, so your inequality symbols, you have less than, then the less than sign with the bar under it is less than or equal to, greater than, and then the greater than sign with the bar under it is greater than or equal to. All right, so there are going to be two other parts to our solution or our answer that they will want you to give. Of course, we talked about the solution set after you go ahead and solve your inequality, but also you will have a graph part and an interval notation part. And so, of course, we'll talk about that as we progress forward, what it means to graph. We're just talking about graphing on a generic number line. But when you have less than or greater than, you should be using parentheses. That means you will exclude that value. Less than or equal to, greater than or equal to, brackets. That means you will include the value. Negative infinity and positive infinity will always use parentheses because you cannot include infinity. You can always go to that next number. So you will always use parentheses on your infinity sign. So before we go into using those, I want to make sure we understand what I mean by exclude and include. So we go back to the 2. Okay, so if I have x is greater than 2, we mentioned it already that we want all values that are greater than 2. So that means 2 is not included as a part of the solution set. If I want all values greater than 2, then 2 is not a part of that. I can get close to 2. I can get it as close to 2 as I like. I can do 2.1. I can do 2.0001. I just cannot use 2 as a part of my solution set. I need the values that are greater than 2. Now, if it says greater than or equal to 2, and I made that too close. I don't want you guys to think that's connected. So greater than or equal to 2, that's all values that are greater than or equal to 2. That means 2 is included as a part of the solution set. So 2 would work because it says or equal to 2. So that's what I mean by included and exclude. So now, if I want to go and show the other piece of that, so for x is greater than 2, if I wanted to graph, let me do this. Generic number line, just make sure we're clear with that. Has 0 in the middle, 1, 2, 3, all positive values to the right of it, negative values to the left of it. So that's the number line we're talking about graphing on. So on your number line, no matter what's going on, if you're talking about values that are greater than your number, they will be to the right of it. Values that are less than that number will always be to the left of it. So if I'm looking at positive 1, I want all the values that are greater than 1. It will be all of the values to the right of 1. All the values that are less than 1 will be to the left of it. Same thing with negative 2. All the values that are greater than negative 2 will be to the right of it. All the values that are less than negative 2 will be to the left of it. So when I look at the solution set, x is greater than 2, I want all of the values that are greater than 2. So you put 2 generically in the middle of your number line. All the values that are greater than 2 will be to the right of it. So I will be shading to the right. And so don't forget though, the greater than symbol, if you go back to what I said, we'll use parentheses. So I will do an open parentheses, and like I said, shade to the right. Now, interval notation, if I recognize reading my graph from left to right, I'm going from 2 to positive infinity. That arrow over here represents infinity. So that's 2 to positive infinity. Keep the same notation. If I use parentheses in my graph, I need to use parentheses in my interval notation. And then remember, I also said that parentheses will always be used on your infinity sign. So those are your 3 pieces of information that they may ask of you. You should be able to give either one. Each piece should reflect the other. And so if you only had one piece, you should know how to write the other 2 pieces. And that's how that's supposed to work. So if I have x is greater than 2, 2 in the middle, but this time I'm going to use a bracket and I'm shading to the right. Still want all the values that are greater than 2, but the bracket lets me know I'm going to include the 2 as a part of my solution set. And then this is going 2 to infinity, but because I had bracket on my 2, because I have the or equal to sign, I should still have a bracket over my 2. And once again, your infinity sign will always have a parentheses next to it. So before I do a generic chart of all of those symbols, questions on anything I've written or anything I've said up to this point? All right, so in here, A and B are going to represent real numbers. All right, so generically, x is greater than a. So if I want to graph that, so the left side of the solution set is if I came down, solve x is greater than a, that a, like I said, represent numbers. So just like we had that 2 right there. So we're just talking about generically, not putting a 2 on it, not putting a nothing, no number. How would my answer look? So if I had x is greater than a, and I want to graph that, I will put a, I want to stay black, parentheses over the a and shade to the right. Then my interval notation, a comma infinity, using parentheses on both. Here I'll use bracket, shade to the right, a comma infinity, bracket on a, parentheses on the infinity sign. Next one, we're talking about values that are less than a. So I'm going to use parentheses, shade to the left. Here I'm using bracket, shade to the left, because remember values that are less than a will be to the left of it. Now for your interval notation, make sure you're careful. A lot of times people make a mistake with this or reading it from left to right. So what's furthest to the left is negative infinity. So we're going from negative infinity to a. Parentheses on both. Here, negative infinity to a. Parentheses on your infinity sign, bracket on your a. All right, so here, this will be the result of a 3-part inequality, and we'll talk about that when we go to solve. So we have x is greater than a but less than b. So we look at the number line. A and B would be up there, and we talk about the values that are in between A and B. They're greater than A but less than B. Both of them had a less than symbol, so we do parentheses over both and just shade in between. Next one has the or equal to attached to the A, so we have a bracket over A, parentheses over B. This one is parentheses over A, bracket over B. And last one, bracket over both. Interval, the shading is going from A to B, so that's A comma B. And parentheses should reflect the same in both cases. So there's parentheses on both, bracket, then parentheses, parentheses, then bracket, and then bracket on both. All right, any questions so far? All right. So we'll solve these linear inequalities the same way we would linear equations. Uh, linear inequalities the same way we would linear equations, not inequations. Equations, we just have to consider one thing. So all right, so when solving inequalities, if you multiply or divide by a negative number, then you must change, or some people like to say flip, the inequality symbol. All right. So if I have negative 3x is greater than 17, I need to solve x by dividing both sides by negative 3. Negative 3 on the left cancels, leaves me with x is greater than negative 17 over 3. Now it needs to be greater than, less than. So because of dividing by a negative, it goes from greater than to less than. So that's what we mean by changing your inequality. When you divide or multiply by a negative value, you have to flip or change your inequality symbol. All right. So if you had to do the other pieces as well, graphing that negative 17 over 3. You want the values that are less than negative 17 over 3. So I'm going to shade to the left. And because it's not or equal to, we use in parentheses. And then for my interval notation, that's negative infinity to negative 17 over 3. Parentheses over both. Any questions? All right, so if I have 3 minus 2x less than or equal to 11, want to solve. Just like before, subtract 3 from both sides. 3 will cancel. Negative 2x less than or equal to 8. Divide by negative 2. X is, once again, we divide it by a negative. So that less than symbol turns into greater than. That is my solution set. Oh, I forgot to do your graphing stuff. So if I had to graph, that'd be negative 4. If we're talking greater than or equal to, we're going to shade to the right, but use a bracket over the negative 4. And then that'll be negative 4 to infinity, bracket, parentheses. All right, so here we got x plus 3 over 4 greater than x minus 2 over 3 plus 1 over 4. I would find the LCD and multiply across the equation so I don't have to deal with fractions. So I will clear out my fractions. LCD is 12. Remember, we did the same thing when we had equations like this. So once again, it's the same process. All right, so 4 goes into 12, leaves you with 3. 3 goes in 12, leaves you with 4. 4 goes in 12, leaves you with 3. All right, so now let's go ahead and simplify. 3 distribution with the 4. And that'll be 3x plus 9 is greater than 4x minus 8 plus 3. You can combine the like terms over here. 3x plus 9 greater than 4x minus 5. Doesn't matter which term we decide to move. I'll do this to emphasize something. So I added 5 to both sides, subtracted 3x from both sides. So the 3's cancel out on the left, the 5 cancels out on the right. 9 plus 5 is 16. Oh, I said 16 and 15, 14, excuse me. All right. So we have 14 is greater than x. But in my math lab, 9 times out of 10, they want the x to be on the left-hand side. So if you have any confusion, just remember which way the mouth of the symbol is open. So if you need to switch your sides, the mouth of the open is set towards the 14. So when you switch the x to the left side, the mouth of the symbol should also be set towards the 14. You can kind of look at it that way or remember it that way. But you do need to keep the same relationship when you go from the x being on the right side to the x being on the left side. So you want the values that are less than 14. So use parentheses because you didn't use the or equal to sign, or they didn't use the or equal to sign. And also my interval notation coming from negative infinity to 14, parentheses on both. Any questions? All right, so a three-part inequality. Those last four rows in that chart is the result that you will get from a three-part inequality. Call it three parts because you have 1, 2, 3 parts. And just like when you're solving, whatever you do to one side, you have to do to the other. So whatever you do to one part, you have to do to the other in order to keep your equivalency. So just like if I didn't have this left side, I have 2x plus 1 is less than or equal to 3. The first thing I would do to solve is subtract 1 from both sides. So remember from that chart, x is supposed to be in the middle. So your goal is still to get x by itself and to leave it where it is. So if I'm going to subtract 1 from one piece, I need to subtract 1 from all 3 pieces. Once again, is to leave x in the middle. So it'll be negative 4. That's going to be 2x in the middle and 2. Now we divide by 2. So that would be negative 2 is less than x, less than or equal to 1. Questions? Any questions? Oh, let me get the other pieces. Parentheses over the 2, bracket over the 1, shade in the middle. And going from 2 to 1, look the same. All right, let me see that one. Let's go with let. All right, so absolute value inequalities let u be an algebraic expression and c be a positive number. You have the absolute value of u is less than c. So the key here is going to be the less than. If you see that less than symbol, then you're going to set up your equation or your inequality this way to solve. If you see the greater than symbol, you can set up your solving this way. So it's all about what symbol you actually see initially. And the same thing holds true if you had the or equal to symbol there. All right, so let's try it out. All right. Absolute value of x minus 4 is less than 3. So because we see the less than symbol, that lets us know we're going to use number 1, the relationship of number 1. So notice what's going on here. The absolute value of your quantity is set less to a number, is less than a number. So what you're going to do is set it up with its opposite on the outside. Use the algebraic expression that was on the inside of the absolute value for your inside piece of your inequality, and then use the number itself, that positive number. So now we can solve. the three-part inequality by adding 4 to each piece. So answer is 1 is less than x and x is less than 7. And once again, they'll tell you what you need or what they need from you. I'm just giving you each piece so you'll get comfortable using them or seeing them. All right, let's try another one. So here, if we were going to do our same comparison, first thing we recognize is that the absolute value quantity is on the right side. When we go back to what we were looking at, our absolute value quantity was on the left side. So we switch that so we can make a clean comparison into what we should do. So the absolute value of 5 minus 2x is greater than 7. That's how that should read for us. And because it's greater than, that means we're going to look at the second way of setting up the problem. And so you take the quantity that you have, 5 minus 2x. I'll do it this way. Use the opposite sign and for your inequality and for your number. And then you write it the way you see it without the inequality sign. I mean, without your absolute value sign. So one of your pieces should be writing it the way you see it. 5x minus 2x is greater than 7. Then the other one should be 5x minus 2x. 5 minus 2x is less than negative 7. So we use the opposite inequality sign and we use the opposite sign as far as the number 7 goes. All right, I see a question. So when you have greater than, when you have your greater than symbol, the way you set it up, if you go back to where you have what you got right going on right here, you use the opposite sign. So we had greater than originally, then we're going to use less than. And then if we had a positive C, we should use a negative C. So that's one piece. And then the other piece is writing it the way you actually see it. All right. So we use the opposite symbol. We had greater than, so now we're using less than. We had a positive 7 and we're using a negative 7. So that's one piece. The other piece is just writing it the way you see it. 5 minus 2x is greater than 7, and that's the other piece. And so you only do that when you have a greater than symbol. Once again, going back, if you have a less than symbol, you set it up this way. Well, that wasn't set up. You set it up this way. All right, so go ahead and solve your inequalities. Subtract 5 from both sides. So that's negative 2x less than negative 12. Negative 2x greater than 2. Divide by negative 2. So those negative 2's cancel. And don't forget your inequality. Whenever you divide by negative, needs to change. So on the left, I have x is greater than 6. And then on the right, x is less than negative 1. So both of those are part of your solution sets. And really there's an or in between there. So it should be x is greater than 6 or x is less than negative 1. If I were to set up my number line using negative 1 is 6, I want the values that are less than negative 1, so I'm shading to the left. And I want the values that are greater than 6. So I'm set my parentheses up, shade to the right. So then my interval notation, I'm coming from negative infinity to negative 1, comma. And for interval notation to represent or, we have a union sign, the union symbol. And then we're going from 6 to positive infinity. All right. Questions on what we did before we do another example? All right. Let's try another one. All right. Negative 2 times absolute value of 3x plus 5 plus 7 greater than or equal to negative 13. All right. So what we would do is isolate our absolute value. So take note. Let me drop down here real second. 1 second. Let's say if I had the absolute value of x plus 7 is greater than negative 5. This right here should be all real numbers because your absolute value will always be greater than a negative. We talked about that a little bit when we had the absolute value equations. So in the same fashion, if I want to know when is the absolute value of x plus 7 less than negative 5, that answer would actually be no solution. Because absolute value is never less than a negative. So don't forget your absolute values. If I take the absolute value of 3, the answer is 3. If I take the absolute value of negative 3, the answer is still 3. The absolute value is always a positive. The application of absolute value is always positive. So if you're asking when is the absolute value quantity greater than a negative number, that's always the case. So any number will work. If you're asking if your absolute value, or when is it less than a negative number, the answer is never. So your answer is no solution. So just throwing that out there. Now, oh, somebody's taking a picture. All right. So Now, when I come to this one, that doesn't apply because my absolute value quantity is not isolated yet. So we have to isolate our absolute value. So I can't look at this negative 13 and say no solution because my absolute value is not isolated like it is down here. All right, so let's go ahead and do that. Subtract 7 from both sides. It's negative 2, 3x plus 5, greater than or equal to negative 20. Now we need to divide by negative 2. Negative 2's cancel. So we're looking at the absolute value of 3x plus 5. Now, don't forget, once again, we divided by a negative, so this greater than symbol needs to change into less than. And we have 10 on the right. Oh, do this first. Any questions before I go to the next step? All right, so I'm gonna bring that down here. So we had the absolute value of 3x plus 5 is less than or equal to 10. So now because it's less than, we need to set it up this way. All right, so from here, I can subtract 5. 5 cancels in the middle. So it's negative 15, 3x in the middle, 5 on the right. Now we can divide by 3. 3's cancel in the middle. Negative 5 on the left, x in the middle, positive 5/3 on the right. Questions? Any questions? So because both of them have the or equal to symbol, using brackets, want the values that are in between them, so we shade in the middle. And your interval notation should reflect the same thing. All right. Questions, concerns, comments on anything? All right. So it will be important for you guys to try this stuff out this weekend. So yeah, Monday, I will leave open for you guys to ask whatever questions you want to ask. So I would suggest that you at least take a look at the test review to see if there's anything on the test review you most definitely want me to talk about going into your test. So don't forget the way we're doing your test, at least the first few of them, since you'll be taking them on your own. But I do need to see, once you've done your submission, I do need a copy of your scratch work. And so you get 2 shots to get the best grade possible. And that's how you'll do that. It's not timed, so you can go in there and knock it out at your leisure. Questions, concerns, comments, anything, anybody? Questions on what we're doing Monday? Like I said, it'll be a review day, so I will not come with anything new to discuss.
Hey, Professor, I had a question. So that practice test on my math lab, is it gonna be just like the test?
Now when you say practice test, are you talking about the test review?
Yeah, that test review on there.
Yeah, it's gonna be very similar to it. Yep, very similar.
Okay, but where do we find the actual test at? Is it like under like test or something?
Yeah. Like, so you should see a homework tab that you will click on to get access to your homework. And then there's a quizzes and tests tab. So you click on that, you should see access or get access to your tests.
Okay. All right. Appreciate it.
Am I on the right math lab? Ms. Laster, you say, am I on the right math lab? Not sure what you mean by that. Are you asking me, do I see your name there? And for car, is there a due date for the test? As of right now, no, I have not set a due date. I probably will set one eventually, but you know, you don't want to let that just linger out there because eventually we're going to go to chapter 2. And so you don't want to have chapter 1 stuff just sitting there. You want to go ahead and knock this stuff out, you know, as soon as possible. So, yep. So no due date as of yet, but I wouldn't put a due date out there and say it's like tomorrow, you know. So I will give you, give me 1 second. I will give you most definitely enough time, ample amount of time, set a due date out there a week, 2 weeks in advance, and you'll know that it's there. Somebody was saying something. Hello?
Can you hear me now?
Yes.
Okay. Yes, because I see vocab and everything up there. So I'm just trying to make sure that I'm even doing the right stuff before I try to do everything, and half of that is not even what you want.
Okay. I'll go in there in a second. Before we close out, I'll go in there and check it out. Let me see if there are any other class issues, and then I'll get you specifically.
Okay.
All right, cool. Anything else before we dismiss? Anybody good? Everybody straight? Any other class questions? All right. So you guys have a great weekend. Be safe. Have a good one. See you on Monday, hopefully with a review, and take care.